Hey guys, I'm going to teach y'all today how to calculate molar mass and percent composition. In Texas, this is the TEK 8C. Actually, calculating molar masses isn't even a part of the TEK, but you can't calculate percent composition unless you know how to calculate a molar mass. So the first thing is, what is molar mass? It's kind of self-explanatory that it is the mass of 1 mole of any compound. Remember, chemists don't count out atoms. Instead, it's a lot easier to just take the mass of them using the periodic table. So essentially, if you want to be able to calculate a molar mass, you need a chemical formula. You need to know how to count atoms within the formula and then find the atomic masses on the periodic table. That would be the number underneath the atomic symbol. So if the first thing we're going to have to do is start with a chemical formula, it is possible that you would be given instead a chemical name such as calcium phosphate. So the first thing you'd have to do is change your name into a formula, calcium having a +2 charge, phosphate being PO4 with a -3 charge. By the time you've crisscrossed your charges, you get the formula Ca3 parentheses PO4 2. You should know how to do that by now. So to count the atoms, in this formula you have calcium, phosphorus, and oxygen. This 2 is going to have to be distributed within the parentheses. So you're going to have to multiply by however many, whatever number of the atoms you have within the parentheses, you multiply by the number outside the parentheses. In this case, calcium has 3 atoms, phosphorus would have 2, and oxygen would have 8. So something such as aluminum nitrate, if we wanted to calculate the molar mass of aluminum nitrate, you'd have to do the same thing. You would first get aluminum and its charge. Nitrate is NO3 with a -1 charge, and so the formula is Al parentheses NO3 3. So calculating molar masses is really easy. The first thing you're going to do is you're just going to list your elements. You go ahead and you just look at the formula and list out the elements. Remember, there is no lower and there is no element on the periodic table that has 2 upper cases. So in this case, you just have 3 elements, aluminum, nitrogen, and oxygen. Once you've listed your elements, go ahead and list how many atoms of each element there is. That's by looking at the formula once again. Here is an understood 1 atom of aluminum. Remember, we distributed within, so there's 3 atoms of nitrogen, and then there's 3 times 3, which is 9 atoms of oxygen. Once you have that, remember this is called the molar mass, so we need to look on the periodic table and write down the mass of each element. I want you to do it to 2 decimal places whenever you round. Do not over round and try and round to whole numbers. Every time go to at least 2 decimal places. What you're going to do is that 1 atom of aluminum that weighs 26.98 contributes 26.98 to the formula. I've already multiplied across here, but each of those 3 nitrogen atoms contribute 14.01 grams for a total of 42.03. These are what I call the parts, and once you take all the parts and add them up, you'll get what I call the whole. The whole is the molar mass. So in this case, the molar mass of aluminum nitrate is 213.01 grams. So the next step is to just move 1 step over and do what's called percent composition. What that is I always say part divided by whole times 100. If we wanted to know the percent composition of boys in a classroom, well, to do this, you would need to know the number of boys, which would be our part, and then you would need to know the number of people total, and then multiply by 100, and you would have the percentage of boys within the class. So in this case of what is your percentage grade, if you were to get 16 out of 7 questions correct on a test, well, 16 would be the part you got correct, 27 would be the whole or the total, divide and then multiply by 100, and in this case you would have made a 59.26%. So it's pretty easy. One thing that always kind of messed with my mind is looking at Planters mixed nuts. It claims on the container that it's less than 50% peanuts, but if you count all of the nuts within this, there are way more peanuts than any of the other nuts. So the way they must be doing this is calculating it according to mass. And that's what percent composition is. Percent composition tells us how much of a certain element is in a compound according to the masses, not according to how many. So if we go back to the case of aluminum nitrate, if I wanted to know the percent composition of aluminum within aluminum nitrate, well, my part that's aluminum would be 26.98, and if I will divide by the whole, which in this case is the 213.01, and then multiply by 100, I would get that it is 12.67% aluminum. If you do this again for nitrogen and do this again for oxygen, you would have 3 different percentages, and all 3 of those should add up to 100. You have to have the whole compound. So molar mass, this number down here, and then percent composition is when you take into account how much of each element is within the compound. That's a pretty easy thing to do. So now you can practice on your own.